good evening. Let's start. Any doubts till last lecture? Like, okay, so we'll start. We'll start with the equality checking protocol. I know that I said in the last class that we'll do the questions. Yes, we'll do so. We'll after the basically after completing the topics, we'll start with the questions as well. I want that these topics should be clear to you. So, what is this allies equality checking protocol? I'm having the there is an allies and there is a Bob basically, and the files are shared basically. The files are with both of them, and I have to check that both of the files are same or they are not same. And for checking that both of the files are same or not same, I want that they shouldn't communicate so much of bits or whole file. They shouldn't communicate in order to check that. So how I can check without sending whole file? That is what they are trying to say now. One brute force approach is like, okay, send the A file. On the other hand, Bob will check match that whether A and B are equal or not. That is the brute force approach. Can you tell me, like, can someone tell me what can be the disadvantages of this, like sending the whole file? Why to design a communication protocol, or why to send the less number of bits? What are the advantages or disadvantages? Can you tell me? Yes.
The cost is
Yes.
the cost is disadvantage.
Yes, the cost is a disadvantage, bandwidth, time, basically, so much of time will be there. And the these network-based complexity, and these all are the disadvantages which we'll face. So let's basically try to send minimal number of bits and check that on the bob end that whether they are basically matching or not matching. I'll write and then we'll solve the same example, like toy example, how they are trying to do it. Though they are trying for a large number of bits. So let's see. They come up with the probabilistic protocol or a algorithm basically. What they say is, okay, okay, turn A into number. I'll have an example side by side. Let's see. NA is equal to summation of 0 I n minus 1 AI 2 power I. Can someone tell me what is this? What they are trying to convert A into? What does this mean in layman language? What is this? If I have a number, what they are doing? Any idea? Or you also you have the doubt in this step, like what are they trying to do?
Binary.
Binary, okay. What is given is I have binary 101. With this NA, they are trying to convert into decimal. Or I'm speaking the reverse. Binary to decimal. Am I correct? Let's see.
Yes,
Suppose I'm given 101. Okay. Let's see an example. 101. What is the N here? What does N means here?
number of digits.
How many number of bits? I can say 3. So how I'll calculate NA? I'm given N 101. I can say that AI, okay, this is 0, 1, 2. I can say that 1 AI means 1, A0, 1, 2 power 0 plus AI, A1 means 0, 2 power 1 A2 means 1 and 2 power 2. So what is the number I can say? 1 plus 0 plus 4, that is 5. So can I say this step means that they are trying to convert from binary to decimal? Is it correct? Let's see the next step. Now, pick a random number, random prime number. Suppose now NA is equal to 5, which we said, okay, 101 is equal to 5. I'm taking a small number, but obviously it's for the larger numbers. That is why they're doing. Let's see this toy example only. So let us say T is having the threshold range as 7. So what will be the P here? Like how many of them will be there? What will be the set having?
2, 3, 5, and 7.
Yes, 2, 3, 5, 7. Now, this is the second step. Okay, I took T as 7. The third step says compute the residue. NA mod P. Now, what does NA mod P means? What is our NA? That is 5. P, let us took any number from this, that is suppose 3 I took. This is the set which is compromising P belongs to T. These are the T's basically. I mean to say here the maximum number of T, that is 7 till 7. This is basically T, I can say, and P belongs to T. That is, I took any of the number randomly. Suppose I took this basically. What is 5 mod 3?
2.
Now, fourth step, I'll send this RA and P to Bob, which means I'm sending residue of A, that is 2 only, and P, that is 3 only, to Bob. Suppose my, okay, I'll tell you. And suppose my NB number was, suppose the number was 110. 110 means NB is equal to, I can say, what is NB? Yes, come on. Just convert binary to decimal. What is NB?
6.
6. So, which means my NA and NB are actually not matching and I'm trying to compute it. So, suppose this 2 and 3 are sent. Now, in this also, I'll basically do RB is equal to NB mod P. So, basically 6 mod 3. I'm given the 3 here, which is equal to basically 0. And I know that 2 is also sent to me and 2 is not equal to 0, which means NA is not equal to NB. You got the idea? Like I tried to do it so that maybe it was discussed like this only in the class. So I tried to explain more intuitively, like what we are doing, nothing, just converting a binary number to decimal number and then picking a prime number from like, it's not T is equal to 7, it's basically up to 7, basically picking any prime numbers up to this T set. And suppose I picked up 3 and then I computed the like whatever the number mod P, that is 2, and then I send the residual as well as the P to the Bob, and then Bob also did the same and then check whether my residual is same as their residual. Then if it is same, I can say that A is equal to B. If it's not same, then I can say that A is not equal to B. Though we'll see in the we'll see subsequently that there may be error in this also. With the example only, we'll see this. So clear this example and this algorithm, the intuition behind the equality check is clear.
Yes, ma'am.
Now coming to what is minimum T to get good success probability? So I'll not go in detail how this is basically computed. Whenever we want to calculate number of prime numbers, I'll say up to certain value T, suppose I'll say T is equal to 100. How many prime numbers are there till 100? That is actually if I'm given 2, 3, 5 and so on till I'll say 97, how many of them are there? How we usually calculate is we take the number that is T over log T. Log T basically. So this is 100. Though the number here is 20, actually the number true value, like true, this is basically how we calculate. But actually the numbers are basically 25. It is close to them, not actually equal to them. I'll say here it is approximately equal to, I'll say approximately equal to T over log T, basically log T, base natural. Like this is the formula here. Though I'm not going into detail how how this formula came, because it's a huge derivation and all of those things. I'm not going into that thing basically. And this is 25, but we are getting here approximately 21.6 or 21.7 here, because we are having the small number here, 100 here. As we'll increase the T, I'll say as the T increases, the actual prime numbers count will be approximately equal to estimate, or I can say ratio of actual prime number count, or simply I'll say in the easy language, will be equal to the estimated count as we'll go on increasing. So why, okay, we studied, okay, this is the case. But why, can someone tell me why by increasing, like suppose 100 till 100, I'm getting approximately, we say that 21.6, but actually it was 25. But now I'm saying maybe up to 10,000 or up to this, maybe the actual count will be not actually equal, like 25 it is, then it should be 25. Actually both the estimated as well as the actual prime number count will be equal as as the T increases. So can someone tell me how, like what is the backstory behind it, why it is like that? When I'm increasing the T, the count will be go on the gap between the estimated and actual will go on decreasing, and they'll be equal. Just try. What can be the reason? Come on. Is it like the prime numbers decreases after, like, because if we'll see 2, 3, 5, 7, and when we go on increasing the numbers, the prime numbers usually decreases. Is it the case? So basically, when we are going on increasing the count, the number of prime numbers are decreasing, or I can say that actual prime number count will be equal to the estimated count. That is what this basically says. Now coming to the error. What do you think? Like, okay, we computed this. We saw that there was no error. Can there be error? Let's see. Like, what do you think? in this algorithm, we saw that, okay, we calculated, okay, this was 0, this was 2, and when they are not equal, the residuals are not equal. Can it be the case that when numbers are not equal, but the residuals can be equal?
Yes, ma'am.
Why it can be equal? Like we have sent it p, it shouldn't be equal now. Some intuition, like what do you think? Okay, let's see. So what I'm trying to say is, these are if A is not equal to B, sometimes the RA is equal to RB, and I'll say, okay, the file which is sent from Alice to Bob, they are equal, but actually they are not equal. We know that RA is equal to NA mod P, and RB is equal to NB mod P. This is okay, we know this. I'll again try to like come up with the example first of all. And I'll also come up with, first of all, write this. Then I'll tell what is this basically. So what was this clear in the class, or there was a confusion in this? So NA is equal to 15 and NB is equal to 10. So NA minus NB, I can say that is equal to 5 here. I can say that. And basically the, okay, let's take example only rather than taking this NA is equal to 15. Suppose I take A is equal to 10 and B is equal to 4. So NA minus NB, I can say that is equal to 6, I'll say. And what are the divisors of 6? 1, 2, 3, and 6. How many? And what is T? Suppose I take T prime numbers. I'll come to you. I'll come and explain. Don't worry. Prime number less than 8. So what will be T?
2357.
Okay, 2357. Now, what I'll say, what I'll check is there anything common? Simply I'll check it. Check this. Is there anything common?
2 and 3.
2 and 3 are common. So, which means that there is a chance that the error can be there. How? Suppose I take 10 mod 2. Here the number is 10 and here the number is 4 as we have taken. 10 mod 2 is equal to 0. And here the number was 4 mod 2 is also equal to 0. So when NA mod 2 is equal to 0, I send it residual 0. And when I did 4 mod 2 is also equal to 0, which means they both are same. And I thought A is equal to B. Similarly, suppose I take A is equal to 12 and B is equal to 6. A is equal, what is NA minus NB? I can say that is 6 only. So I'll take 3, suppose. P is equal to 3. Now, in this case, 12 mod 3 is equal to 0. Similarly, 6 mod 3 is also equal to 0. So according to me, A and B are equal because I'm calculating the mod. But actually, they are not equal. So what is done? Basically, I'll calculate what are the prime factors in NA minus NB. Like when I calculate this, suppose NA is equal to, again I'll come, NA is equal to 15, NB is equal to 10. Na minus Nb is equal to 5. What are the divisors of 5? The 5 only is there. And suppose I take t is equal to 11. So 2, 3, 5, 7, 11. What is common? 5. So how much probability, again I'll come, how much probability is that there can be the error? How many prime numbers are there? 1 divided by 5. So let us see again. Number of prime factors, Na minus Nb. Number of prime numbers in T. Number of prime numbers in T is 5. How many are prime numbers here? 1 only. 5 is only there. So 1 by 5. When we solve 6, okay, let us come here. How many prime numbers are there here? How many prime numbers are there? 2. How many numbers are here total? 4. So 2 by 4, which means 50% chances are there the error can be there. How the error is coming? Because we are taking the common, basically. Suppose we are taking 2 here. So 2 can be basically, when we subtracted 10 minus 4, 6. When we basically subtract, we see that there are common, or I can say 2 and 3. It can be, suppose 10 mod 2 is also equal to 0 and 4 mod 2 is also equal to 0. Basically, the modulus is equal to the same modulus, but the numbers are different. Are you getting my point? What is the intuition? We are calculating the modulus and then only checking the residuals. So after getting the residuals, the modulus is equal to same. There can be the same modulus result, but the numbers can be different. That is what it is shown here. And how much error, how we calculate the error basically? We calculate the number of prime factors between Na minus Nb. How many factors, prime factors are there? So factors basically 1, 2, 3, 6. So 1 into 6 is equal to 6, 2 into 3 is equal to 6, 3 into 2 and 6 into 1 is equal to 6. So how many prime factors are there? 2 prime factors are there only. And how many prime numbers are there in T? Basically 4 prime numbers are there. So 50% of chance are there that I can have the error when I am having this case, basically Na minus Nb, basically Na is equal to 10 and Nb is equal to 4. Are you getting?
Yes, ma'am.
So is it clear like how the error is there? Basically, how many prime factors are there? I'll calculate between them, divide by prime T. And we saw that sometimes the modulus of them are equal, but the actual number is not equal. That is the reason when we are communicating, the error is coming here. So, okay. I can write it as, okay, I'll not go in, maybe you can see how they have done that thing. I'll not go in detail of this derivation and all. Now coming to Poisson random variable. Can someone tell me about this? Yes. How are the classes going? Like you are understanding or there are doubts like in the concepts as well? First, I want to take the feedback so that I can focus more on in the next classes on those things. Are you liking that? Okay, we are repeating and we are going in depth of the each, or you want that? Okay, only the problems should be solved. Yes. You can give the
No,
feedback.
ma'am. It is good that we are discussing in depth also, because some of the things we can't understand in the lectures.
Okay, okay, okay.
Actually, the
That
definition of Poisson variable is not clear.
okay, 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 okay. So basically, if I talk about Poisson random variable, it has the property that okay, I'll first go to binomial. So binomial random variable, binomial we discussed in the last class. Can someone tell about binomial random variable if it's clear, or I can again discuss it. Don't worry about that.
When Bernoulli test, when Bernoulli tests are repeated again and again, it converts to binomial random variable.
Yes, 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 absolutely correct. So basically, when we are repeating the Bernoulli, I can say we are basically coming to the binomial random variable only. That is, suppose I am tossing a coin. Bernoulli means I'm tossing a coin, either head is coming or either tail is coming. Basically, either success is there or either failure is there. When we are repeating this again and again, or some of the Bernoulli random variables, we'll that is basically binomial random variable. And we also saw the formula, how we came up with this formula in the basically we are choosing ncr, we are choosing r out of n. What is the probability of two and what is the probability of the success and what is the probability of the failure here? That is 1 minus p only. So are there any doubts in this?
No, ma'am.
Okay. Now, the Poisson random variable, it basically is the extension of the binomial random variable only. It's like, suppose I'll say I have large number of n, and I'll say I'll have smaller p, very small p. Then if in this case we use mostly Poisson distribution, basically Poisson random variable basically. When I have large n, suppose, can you give me an example when we have large number of instances, but the probability is very less? Think of something.
Like phone calls,
Okay, how n is large and p is small?
ma'am, because the interval is very small, but there are large number of intervals. So
Mm-hmm.
so in any interval, many phone calls can come. So that
Yes, yes, yes,
so
yes, yes.
probability is very less.
Yes. Or can I say, if I suppose I have a book and I have to go on each and every alphabet and see that which one, with each word, and see that which one is misspelled, which how many spellings are incorrect basically. Obviously, the probability of spellings wrong will be very less, whereas the n number of words will be very large. This can be also the case. So basically I can say when n reaches infinity and p reaches 0, basically when n is very large and p is very small, we use this Poisson distribution or Poisson random variable, I'll say. So suppose the example was also given to you. So x is the random variable and k is any number we have to calculate. So we divide into number of discrete parts basically. Suppose that is the expected value of this is alpha. Okay, I'll take the example of that only, calls and that. The expected value is alpha, basically the call. I will also solve some numerical examples also. Suppose calls in 12 to 1, same example I'm taking. And x is the number of calls in 12 to 1 p.m. So call in one part, basically I'll say alpha by n directly. N parts I have divided the call of 1 hour into n parts I have divided. So going to binomial distribution, what is the x is equal to k? Can I write the, this is the formula of the binomial distribution only, nothing extra I can say. Is it fine, the formula?
Yes, ma'am.
I'll write, you have to tell me, like you guys have to tell me how I'm going to the next step. I'll explain, wait for a minute. Now, can you explain me this and this?
Yes, ma'am.
Hmm.
Ma'am, we have taken them n from each term common and have cancelled it when by when the other n below alpha by n
First
to
of all, tell me how we came up with this. Yes, we'll go to this. How we came up with this?
ma'am nck when we have expanded it
Hmm.
and when we have put the value of p, that is alpha by n.
And 1 minus alpha by n.
Yes, ma'am.
This is basically the same only. I'll write till basically 1 and here write n minus k basically. So this is same only. So that is these and this will get cancelled out. That is why I have written like this. Is it clear how this came? Okay, I'll tell
Yes,
you. 5c3, how we write 5, 4 into 3 factorial.
by
So 3 factorial and 2 factorial and this cancel out. So this is what it is done here. Yes, come on. Then how we came up with this?
we have taken n common from each term, then cancel it to
N common. Okay, n common I took it from here and that n is cancelled from. Okay, I took n common. Okay, you are right. N common, I took 1 minus 1 by n and 1 minus 2 by n, 1 minus k plus k minus 1 by n. Then how it is basically cancelled? Any idea? Okay, this is correct. You said me that, okay, n is common here.
and by n to the power k, that is
And
generated by alpha by n raised to k.
can I say by n power k?
Yes, ma'am.
So basically this and this n, if we'll take common, they'll get cancelled out. They are also k, basically total n power k, they'll get cancelled out. And we came up with alpha power k over k factorial. And here we have split n and minus k. Is it fine? This 1
Yes,
minus
ma'am.
power n minus k, I can write it like this. Now, if I say, so what will be the value of this?
And one
How?
and 1 by infinity is 0 and 1 minus 0 is 1. That's why each term is there.
Actually, your voice is cutting. Can you again, pardon? Can you again speak what you said?
Ma'am, 1 by infinity is 0 and 1 minus 0 is 1. That's why we are getting 1 there.
Yes. Okay. Yes, absolutely correct. We got 1 here. And okay. Okay, I'll write this alpha k over k factorial. What about these terms? Can I? Okay, I'll come to the formula. We have this formula. E raised to power x. Or I can say, if I substitute, this is the formula of e power x. And if I substitute here 1 plus alpha by n, I can say that is e power alpha. And if I say 1 minus alpha by n, this is same as this.
Ma'am, there is also power
Ma'am,
of n
power,
also.
yes, ma'am, power is also
Okay, sorry. Now it's fine. Actually, the formula is power only. 1 plus x by n power n. This is the formula we usually use. So only we have substituted the value as minus alpha instead of this. And obviously this will be also be minus alpha. Is it fine? How we derive
yes,
this?
ma'am. Yes, ma'am.
So this is basically the PDF of our Poisson distribution, I can say. And let us go to the expectation part. So sum multiplied by sum of multiplied by the number itself, we'll calculate the expectation here. So can someone tell me what is the next step? We have missed some step. Or is it correct?
It is correct.
So what is the value of probability of x is equal to nk? Okay, according to the Taylor series, we usually have, I'll say specifically Maclaurin series of Taylor series. There is an expansion of e power x, which means we can write it as x over 1 factorial, or I'll say x power 0 only here. So x power k over k factorial. This is basically the expansion of the Taylor series. And similarly, can I write it like this somewhat? Yes.
Yes, ma'am. Exponential series.
So can you tell me what should be the value of this? Yes, come on.
Ma'am, I don't understand the question.
I'm saying that what is the expected value of this Poisson random variable? So what should be the next step here? I have told you this Taylor series. Now how we'll plug in the values here? We know the problem, okay, I think something we are missing, or is it fine? Are we going fine? The value of, we calculated this basically, the PDF basically. What is the probability?
Sum of probabilities, ma'am, sum of probability is 1.
Sum of probability is 1, I can say. How that is 1?
Ma'am, when we put sigma sign there, ma'am, we get exponential series, and the value of that series is e to power alpha, and that cancel out. That gets cancel out with e to power minus alpha.
So this is basically, as we saw here in the our series, this is equal to e power alpha. Am I correct here by speaking this?
Yes, ma'am.
And this is equal to 1. This is fine. Now we are going to the expectation part. What should be the expectation?
Ma'am, alpha.
How alpha?
Ma'am, when we multiply k there, ma'am, the k factorial gets changed into ma'am k minus 1 factorial. Ma'am,
K.
that's why we ma'am.
I'm not getting you. What is the value of px is equal to k e raised to a minus alpha multiplied by? Yes. Okay.
Alpha raised to k by k factorial.
How this came? How we came up with this?
Ma'am, we solved for it previously. We took limit and got that answer.
Yes. So we got this answer and we plugged in the values and we got this. So I can say e raised to a minus alpha alpha. This is actually e raised per alpha and we got the alpha here. Actually, we solved this and we got this alpha here. Is it fine?
Yes, ma'am, it's fine.
So we saw that in Poisson distribution, n is reaching infinity, p is basically reaching 0. I mean to say n is very large, p is small, and np is basically, what should be np? Should it be also large, small? Basically, how should be the mean here? Should it be large, small, or finite, infinite? What do you think?
It should be finite.
It is finite because one value is very small and other is large. So we consider it as finite only. So let's solve some numerical problems of Poisson distribution. Suppose if 2% of electric bulb manufacturing company are defective, find probability that in 100 bulbs, none is defective, 5 bulbs are defective. So lambda is equal to n into p here. First of all, we have to see whether we can apply here. What is n basically? 2% of electric bulbs manufacturing companies are defective. Find the probability that in 100 bulbs, none is defective. First, let's try to solve this. What is n?
100, that is number of bulbs.
Okay, what is p?
2 by 100.
2 by 100. So basically 100 is very large and this is 0.02. As we saw, we can apply this because that is large and that is very small. So it's better to apply Poisson rather than I'll say the binomial here. So I'll plug in the values e raised to a minus alpha, alpha raised to power k over k factorial. This is the formula. Na? So alpha means here lambda only basically. I mean to say the mean only. I'll either put e raised to a minus lambda, lambda power k over k factorial. So I'll easily get by plugging in the values. This was a normal question. 2 power 0, 0 factorial and e raised to a minus 2. Similarly, I can do for the 5 bulbs also e raised to a minus 2, 2 power 5. It's fine, very easy. Let's go to some other question as well. Suppose, assume that 1 in 80 birth in case of twin calculation, in case of twins, calculate the probability of two or more sets of twins on one day when 30 births occur. So I have to calculate the probability of two or more set of twins, which means x should be greater than 2. What is P and what is N?
Ma'am, N is 30.
N is 30. What is P?
And 1 by 40.
1 by?
Ma'am, 40.
Where is 40? It's 80, 80. Is it like you saw, it was looking like 40 or how you said
Ma'am,
40?
2 by 80. 2 by 80. That's why 1 by 40.
The probability of two or more twins. What I'm saying is assume that there are 1 in 80 births in the case of twins. This is one thing. 80 births in case of twins. Calculate the probability. That is the other thing. Calculate the probability two or more. I'm saying that two or more twins on one day where 30 births occur. When 30 births occur. I'll say that 1 in 80 births. Is it clear?
Yes, ma'am, clear.
So how I'll calculate, is it reverse? Usually what we do
Yes,
is, so what we should do now?
1 minus P of 0 and P of 1.
Yes, absolutely correct. So 1 minus probability of x is equal to 0. What is lambda? What is the value
30
of
by
lambda?
80.
3 by 8. 3 by 8.
3 by 80.
30 by 80 or 3 by 8. So simply plugging in the values. E raised to a minus lambda, lambda raised to power 0 minus e raised to power minus lambda again over 0 factorial. This is how we'll calculate. Next question. Then we'll move to the next part. Between 2 p.m. and 4 p.m., average number of phone calls per minute coming to cell phone company is 2.35. Find probability that during one particular minute, there will be at most 2 phone calls. So what we have to find? Probability of x. Yes, what we have to find? Greater than, less than. What we have to find? Read the question. Between 2 p.m. and 4 p.m., average number of phone calls per minute coming to phone company is this. Find the probability that during one particular minute, there will be at most 2 phone calls.
Less
Less
than
than
equal
equal
to
to
2.
Less than or equal. Okay, less than equal to 2. Yes.
Yes, ma'am, because there is at most 2.
At most 2. Yes. What is n? It's not given, na? And I'll say that p is also not given, but lambda is given to us.
yes, ma'am.
2.35.
Ma'am, lambda is
Yes, yes.
ma'am it's 120.
Yes.
Ma'am, n is 120.
N is
120.
120.
120 minutes.
Okay, yes, we can take that also. Yes, yes, because 2 p.m. and 4 p.m. basically, yes. Okay, but I'll say lambda is there. What is n? N is, are you sure that n is 120? N should be maximum number of phone calls, or n should be the time? Let's see again. Find the probability that during one particular minute, there will be at most 2 phone calls. What is n? If we see in the previous question, here the n is 30 on one day when 30 birth occurs. So between 2 p.m. and 4 p.m., how many phone calls can the number of phone calls can occur? Max phone calls, are they given to us? Are you getting my point?
Okay, ma'am.
Yes?
Ma'am, it's not time then.
I'm not getting you. Yes, what you are saying?
Ma'am, n is number of minutes. That is 120. Can we take that?
N is n number of phone calls or is n number of minutes? Between 2 p.m. and let's read the question again. Between 2 p.m. and 4 p.m., average number of phone calls per minute is 2.35. Okay, average number of phone calls. Find the probability that during one particular minute, there will be at most 2 phone calls. What do you think? N is the number of phone calls or N is the minutes? When we see the last question, what was the N here? The total number of births? 30, as you told. What was the N here? 100 bulbs?
Yes.
Now, what should be the N here? It should be time or number of phone calls? Maybe
Ma'am,
I
number
can,
of phone.
maybe
Ma'am,
number of phone calls. Yes, yes.
one call at a and
One call, find the
per
probability
minute.
that during
Can we
one
take that?
particular, there is not written that average number of phone calls are written, but total number of phone calls between this, they haven't written. Like find the probability that one particular minute, there will be at most 2 phone calls. Yes. Come on. What are your views about this?
Ma'am, how to calculate n then?
Do we need to calculate n?
I think it is not
Yes, ma'am.
because it is not included in PDF anywhere.
We can directly put this formula. Is it fine?
Yes, ma'am. Yes, ma'am.
So 2.35 power 0 over 0 factorial, because x is less than equal to 2. Similarly for 1 and for 2, and then we'll add it up. Is it fine?
Yes, ma'am. Fine.
Let's move to the next. That is concentration inequalities. And one more thing, like if suppose this question is given to me, assume that 80 birds and all, we can also solve through binomial as well. If we think that n is not that much, like suppose in this case, it was 0.8 and n is 30. Let's try to solve it. using binomial, and let's see what's the difference between them. Assume that 1 in 80 births in the case of twins. Calculate the probability of 2 or more set of twins. So as we have done, 1 minus NCR P raised to power R Q raised to power N minus R, that is the formula only. So 1 minus total number of N, we know that in the twins case I'm saying, because we are thinking, okay, N is not that large basically, and P is not that small comparatively. Yes, they are, but let's see. N is equal to 30, 0. P is basically 1 by 80. Q is 79 by 80. 30 minus 30, C1, 1 by 80. So basically, I mean to say we can solve through this way as well. Though the values will not exactly be same, they can be approximately similar, I'll say. If we don't have, if in this case, obviously we can't solve here. Otherwise, we can solve through the binomial as well, if we think that the difference is not that large as well. So coming to concentration inequalities. So basically they tell us how close the mean expected value is close to the actual value. This is the main motive of concentration inequality. Let's go to the Markov inequality. What does it say? For positive random variable x and a is greater than 0, probability x is larger than some constant. It is bounded by expected value of x divided by a, and a is greater than expected x. So what they're trying to say is, this is suppose expected x. So what should be this value? X greater than a basically. Probability of x greater than a. This we have to basically find it. So let's see, this is basically the formula. Let's see the derivation as well. Expectation, I can write it as summation of x into p of x. So dividing less than a as well as greater than a. So this part as well as this part, that is only the total x, I can say. So if I take only this part here, I'll say this will be greater because this part is suppose gone to that left hand side, or I'll say only expectation of x. So left hand side will be greater. Any doubts in this point? Any doubts till now? Should I proceed? Or it's unclear? Again, I should tell.
Yes, I'm clear. Yes, I'm clear.
Okay. Now I know that x is basically greater than a. That we know that the constant is here only and x is greater than. If expectation of x is greater than x, px, I can say the expectation is also greater than a px. If the number expected, if 7 is greater than 5, obviously 7 is greater than 4, I can say. So because 5 is greater than 4, are you getting my point? X is, this is suppose x, this is suppose a, x is greater than a, which means this should be greater than this number also, which is smaller. So I can substitute this there here, a. I can bring A outside. Write it as probability of x greater than A. That is what it is here. X is greater than A, P of x. This is basically this. And this is expected value of x. Any doubts in the derivation?
No, ma'am.
Simple derivation was there. Similarly, this was for discrete. Similarly, I can do for the, I'll just give you an overview for the continuous as well. For the continuous, instead of sum, what we do? Like here, the sum is used,
Ma'am, we
summation.
integrate.
Integrate.
We integrate.
Yes, absolutely correct. So minus infinity to infinity, x fx, I can say dx. So minus infinity to 0. I'm not going to solve, just I'm writing here like x fx dx. And we are only taking the positive where x is greater than 0 here. So we'll only consider this. I can write it as 0 to a to 0 here. A to infinity here. And if I take only this part, again, I'll say that this is greater than a to infinity. A, again, I can write instead of x, a basically. And similarly, I can get it with. Is it fine?
Yes, ma'am.
So random variable here is non-negative, and we only require the expected value for the computation, basically, for the computation of the Markov inequality. So suppose let's take some toy examples to have some intuition behind this. Coin is weighted, so that the probability of landing on heads, though it can never be the case, but still, landing on heads is 20%. Suppose coin is flipped 20 times. Find bound of probability it lands on heads at least 16 times. So which means I have to calculate, first of all, go with the last line, x is greater than 16. That I have to calculate. So I have to calculate the bound basically, how much should be the bound here. So what is the expected value?
20.
Expected value is 20. Are you sure? What is n? N is given to me. What is this distribution? Is there any distribution it is following? Coin is flipped 20 times.
Yes,
Landing
binomial.
binomial. Now, what is the expected value, expectation formula of binomial? Is it correct? Number of times coin is flipped, can I say 20? What is P? Now, what is the value? 4? Is it
Yes,
correct?
yes, ma'am. Yes, ma'am.
So, probability of x greater than 16, applying the Markov inequality. Can I say 1 by 4 bound? Is it correct? Any doubts in this question? Okay, let's go forward. One more toy example we'll see. Then we'll move to Chebyshev. Surveys show that student on particular campus on an average, okay, particular campus carry money on an average $20 in cash. You meet student in random. Estimate the chance that she is carrying more than $100. Very easy. Second, also estimate chance she is carrying less than $80. What should be the answer of both of them? Yes, try to solve it on your own. What should be the answer of first? First one is easy, quite.
1 by 5.
1 by 5. And what about second?
That
Yes.
1 by 5.
First one is 1 by 5. What about second?
Second one also.
Okay, let's solve and see. So, what is the expected value? 20.
20. Yes, ma'am. 20.
So, we have to find probability of x greater than 100. So, we know that it should be less than equal to expected x, which is 20 by 100, I'll say. That is 2 by 10, 1 by 5, I'll say that. Let's see second, probability of x less than 80. So I can write it as 1 minus probability of x greater than 80 because so I know about this. This is expected x over 80. What is expected number x? Is it 1 by 5?
No, ma'am.
Don't hurry up. At least don't hurry in class. Oh, don't hurry in exam. Here you can do.
Okay, ma'am.
So, any doubts in this? What about others? Any doubts? So
No,
we
ma'am.
were, okay. So it was like simple. We have to x is less than 80. I have to calculate because I know the formula for x greater than 80. So I did 1 minus and then calculated simply. Now coming to Chebyshev. Okay, before coming to that, I think though we have like discussed about variance in the last classes, like what is the variance, we also derived about that variance is equal to variance of x. And one more point was there, that why we are taking basically the square. Yes, can someone tell why this whole square is taken? Why can't, why, what is the reason behind this whole square?
Ma'am, because deviation can be negative also, so to avoid that value.
Okay, let's see
Ma'am,
if I, yes.
when we add the deviation, then it comes up to 0. That's why we add. We try.
Yes, yes, yes. Basically, when I'll do it, what is expectation of x?
Expectation of x.
Expectation of x
What is the value?
is 0.
So
0.
positives and negatives are basically canceling out. That is why we thought, okay, let's take the let that is why they thought that take the square of them. So, and one more thing, we have studied that variance of x is equal to second moment, basically e of x square minus e of x whole square. So should I derive that, or in the last class as we have done, or we should go forward, or we can also again go how this came basically? Should we go through in this detail how we come up with this formula, or we should proceed? Yes, come on.
Then we said to try it on our own.
Okay, you want to try on your own? I'm not getting what you're saying.
In the last class, when you said us to try this on our own, and that's why
Okay.
I solved it like
So have you done?
yes, ma'am.
Okay, is it solved? Can you
Yes, ma'am.
explain?
Ma'am, I have a picture. Ma'am, can I explain with it?
Okay, can you, okay, I'll stop sharing the screen and you can share and explain this. You can share the screen and explain how we come up with this. Are you able to share the screen?
Ma'am, I am not allowed to share.
Wait a second, now are you allowed? Like now try to share it.
Ma'am, this is the solution.
Yes, can you explain? Okay, this
Yes,
is for
ma'am.
geometric distribution. Yes, yes, that was given. Okay, can you explain?
Ma'am, as a told us, ma'am, the formula for
Hmm.
variance for is expectation of x square minus the square of expectation of x.
Yes.
Ma'am, ma'am, you told us, ma'am, about expectation expectation of x. That's why I have not done it here.
Hmm.
Then we will solve for expectation of x square. Then we can break it into two parts. That is, if the expectation of x is equal to 1, and secondly, if it is greater than 1. And in the first part, it is p, because in the geometric distribution, if we get if we success in the first trial only, the probability is p, and that's why it's p. And in the second part, we need to calculate. And the second part that we need to calculate. That's why we have in the second part, the expectation of x square when x is greater than 1. Then we know that in this case, number of trials is more than 1. That's why we can add 1 to x, and then we can replace x with 1 plus x and multiply q. Because first one is surely a failure. That's why we can do this. And upon expanding it and solving it, when we get equation third, that is expectation of 1 plus x square, and by solving it we get this.
Okay.
Then we put this value in the equation second, we get p plus
Yes,
and
yes, yes.
upon solving it further, putting value expectation of x equal to 1 by p and solving it further, we get a equation 4, that is 2 minus p by p square.
Yes.
Should I explain the calculation part?
It's fine. Okay. Okay, and then
Okay,
substitute the value.
so by equation 4 and equation 1, by substituting the value, we get variance 1 minus p by p square.
Absolutely correct. Very good. Nice. So this is the variance. Basically, this was given as an homework assignment to calculate this, and it's correct only. So nice. So can you also explain how we come up with this variance, the first formula, like expectation of x minus expectation of x whole square? Everything is fine. This is for geometric distribution. How we came up with this first equation which we have written?
Do I need to derive it?
Yes. Oh, this is fine. This is one part, variance of geometric distribution. Okay. We'll discuss. Actually, we have, I think, discussed about how we derived that.
Yes, ma'am. You told us.
I have told already in the class that how we came up with this basically. Nice for this. This is correct geometric distribution. So now coming to Chebyshev, and we also saw this variance of a of x is equal to a square variance of x. This also we saw in the last class. So coming to now Chebyshev inequality. For random variable x and a greater than 0, I'll write it as probability of x minus expected x greater than k sigma 1 by k square. Or as in the class, it is written like probability of x minus expected x greater than a. So how we come up with this first equation to second equation? Any idea? Can I say that here I'm taking it as k sigma is equal to a, or I can say the k is equal to a by sigma. K sigma is equal to a, and if a is equal to k by sigma and k square is equal to a square by sigma square, which is I'm substituting the value a here and sigma square here. Basically, sigma square is variance. So can I say both are equal only? Is it fine?
Yes, ma'am.
Hmm. So how we basically derive this? This is simple only by Markov, though there are, I'm not going to give the proof of the other, how basically we can derive through Markov also. It's nothing, just what is Markov inequality? Yes, come on, like probability of x greater than a is less than expectation of x over a.
Yes.
Now, can I use the Markov inequality here? X minus expectation of x. I'll do suppose whole square greater than a square, and if I'll substitute the values, I'll get, I'm not doing it is same only, the variance of x over a square. So basically I'll get this expectation of x minus ex whole square by a square, and this is variance by a square. The same thing. So now coming to one example also, let us see the example of the Chebyshev inequality. Just this formula I have written. Let's go through how one for example of this. Suppose random variable x has mean and variance 9 and unknown distribution, or I'll simply write mean and variance, find mean 8 and variance 9. So try to solve this. I'll come in 5 minutes. Until then, try to solve this. I'll just come. And have you noted down the formula? Maybe it's in the class also. This is the formula. K sigma, suppose, or the second one, anyone, and try to solve this. I'll come just in 5 minutes. Yes, any progress? Yes. So in which direction you are thinking what should be? So should I? Like usually we are given with probability of okay. X minus expected X like this. So can we eliminate these? Basically, this is our main motive now. Am I audible now?
Yes, sir. Yes.
Mm-hmm. I'll write. Maybe you will get something. Now, any idea?
Yes, sir. Case 12.
Hmm? What should be the next step?
We can convert it into one more form.
Mod. So basically, what I was having in the left hand side and right hand side as well. So what I did some subtraction basically on both of the sides so that they should be both like one should be negative of others, so that I can write in the mod thing. Now I can solve it.
Yes, ma'am.
Yes, sir.
So now what is the formula? We have 1 by k. If I see this, this is k sigma, this is 1 by k square. But I have this greater than. Here I am having less than. So can I say 1 minus 1 by k square? Is it fine? And k sigma, what is k sigma? It is 12. This is basically k sigma as per this formula, k sigma. So k sigma is basically 12. Or I can say that, and what is the value of sigma here?
I'm 3,
3. What is the value of k?
4.
4. And now what is the bound? 1 minus, it is basically k square, sorry. 16, which is equal to 5 by 15 by 16. Is it fine? Any
Yes,
doubts?
sir.
So should we proceed? So we got a
Yes,
intuition
ma'am.
behind this also. So let's go to weak linearity of expectation. I can say that let I belongs to, given that I belongs to N, be two-wise independent. What do you mean by two-wise independent random variable? Any idea?
Pairwise?
Basically, two variables I'm taking and then pairwise, basically, I can say. Then variable of I, xi, Can I say this is the linearity property I have applied, that I can simply go through this. Sigma, basically keeping the variance there inside, nothing is in. Now, how variance of xi, we have now only done that. What is the formula of variance? Whole square minus expected value of expectation whole square minus x square minus something. Is it like this, or something incorrectly I have written, or expectation of x square minus expectation of x whole square. X square and x whole square. Okay, let's go forward and then see. So what I mean is, two pairs I and j I'm taking, multiplying by xi and xj. If they are different, which means now they are not same, the both of them are not same, xi and xj, and here expected value of xi multiply by expected value of xj. This I mean to say, this is the variance only, expected xi whole square minus expected summation of xi square, which means expected xi, expected xj. Is it correct? Now what should be the value? What should be the answer? If I'm writing xi as xi and xj, I have two pairwise. Now what should be the answer here? Yes, random guess. Or if you know, what do you think? Come on. Okay, let's see. If I say that expectation of x1, x2, summation of two variables I'm taking, k1, k2 belongs to our random variable, x1 is equal to k1 and x2 is equal to k2. K1, K2. Basically summation multiplied by K1, K2. That is only we are doing the expectation of them. Is this fine? Expectation is equal to sum multiplied, sum of the probabilities multiplied by the number itself. That is what I have written. Now, sum of K1, K2, probability of X1 is equal to K1. I can separate them out, multiply. How can I do it? Why? What is the condition I can do this? Intersection is equal to this. How I came from the first step to the next step? Can someone tell me? What is my assumption that is why I came here? This was intersection. I have written
Pairwise independent. Pairwise independent.
Correct. Basically, they are independent. When they are independent, I can simply multiply them. Is it correct?
Yes, ma'am.
So now I'll separate this summation as well. Similarly, summation over K2, probability of X2 is equal to K2 into K2. So what is this?
Expectation of x1.
Yes. Summation into the number, with this is expectation of x1 and this is expectation of x2, which means expectation of x1, x2 is equal to expectation of x1 multiplied by expectation of x2.
Yes.
Or I can say that, in other words, that expectation is multiplicative on random variables or on independent random variables? Because because they were independent, that's why I was simply multiplying them. Now what will be the value of this? What is this? What is this? Sorry. Come on. Come on, come on.
They get multiplied from their expectation.
Huh, yes.
Their expectation gets multiplied.
Multiplied, then what should be the value? Then both of them are same.
Yes, ma'am.
If both of them are same, it's 0. So basically, we come to this. So can I write it like this? Because for the both of them, I can't write, they cannot be different. Basically, they are same only, then only the expectation we can calculate as we saw there.
Yes, ma'am.
So we have though discussed about this, that linearity of variances also, we can follow this rule basically. That is what we came up with that. So if xi's are same only, then only, otherwise we'll get this, and this is equal to summation of I. Now going to weak law of large numbers. Before going to that, what do you think? What is the intuition behind that? Okay. If I say that, I'll go from bottom up approach. What does this mean as n tends to infinity? As far as mean, expectation of x is expected value. What does this mean? Why we calculate this? X bar, I'll write it. Let's see where it is used basically. Is it used in any of our computer science subject? You are from computer science department.
Yes, ma'am.
What about other?
Yes, ma'am. Same
Okay.
computer.
Okay. So where we use it? Do we use it? Usually, when we do the code, what we do is I calculate. Sometimes I'm not confident. I am basically, suppose we are not confident, we have to run that code multiple number of times so that we can calculate this x bar value, so that it should be equal to the actual expected value. Basically, we call it as sample mean here, and this is call it as population mean. What our main motive is that our sample mean should reach the population mean. Okay, I'll not go into technicalities. What I mean to say, sometimes I run the same, why we run the same experiment? Because some of randomness is there. Suppose sometimes random number, this will be selected, sometimes this will be selected. So I am running this experiment for run 1, 2, suppose run 100 or 1000, many number of times I run it, so that the expected value, the number of time, then I'll calculate the expected value, the mean of them, that should be equal to the expected, that should be equal to the true expectation or the population mean. Are you getting it? Whenever the randomness is present in our simulation, then we basically try to run it number of times. That is okay. I'll not go to more detail in this. Just an intuition. You got the intuition why we run our experiment number of times when randomness is there, so that we can calculate the mean of that at the expected value of that, and the expected value should be equal to the actual mean. Do you got the intuition behind that?
Yes, ma'am.
Yes. Now that is what weak law of large numbers says, that when our mean basically reaches the true mean, the expected mean reaches the true mean. So as the average of independent random variable xi's, each identical to x, probability of x bar minus expectation of x. We have done this. Okay. I'll use Chebyshev here. We have to prove, and then we'll use the Chebyshev there afterwards. First of all, let's try to calculate expectation of x bar. Can I say this is the expected value? Now calculating the variance of that. Again, variance of the mean, that is xi by n. And what should be when what should be if I'll okay, take out the n, what should be the value? Should it be like this? Is it correct? Come on.
N square.
Yes. Basically, a square, whenever we take out n or a constant the outside of the variance, we have the square in this. We have seen there. So as total number are n, let's take it as n into variance xi. And we are saying variance x, as we are saying that each are identical to variance to random variable x. Variance of x by n square, and then we're doing nothing. We are just putting in the Chebyshev formula, where the formula is, this is the formula, and we have this variance sorry, this is the formula. Something wrong. Okay, this is actually n here. Okay, this is the formula, variance x over a square. And now if I put this value, variance of x in this variance of x n a square, will I get this value? Any doubt how I got this? Clear? So basically that is the same, only x bar minus e of x. That is why I put in the Chebyshev, and then I got this variance of x was given. I substituted this and I got this. So basically the main motive is, as n tends to infinity, x bar will basically go to expected x. By repeating the experiments multiple times, will go close to the expectation. So should I start the Chernoff count, because it will take a lot of time? It was complex. Do you what about your experience? Did you find that complex, or was it fine, Chebyshev? A Chernoff inequality or bound. Yes.
Ma'am, I have not seen that video.
Yes. Okay, you haven't seen it.
I have not. Yes, ma'am.
Okay, okay. Maybe because it will take time to understand each and everything in the Chernoff bound. We'll resume this thing from this Chernoff only. We'll go to the. I thought of first. Okay, okay. Then we'll go to like we'll proceed in the next session. So, any feedbacks related to class?
It was very nice.
Thank you. So, thank you so much.
Ma'am, it
So,
was good.
thank you. So I have uploaded the previous videos as well in the on the YouTube. Today only I uploaded. I should upload frequently. Okay. Then I'll upload it after this class only. This one. Thank you so much.